All right, example 14 now. Example 14, referred to the origin as O. You have 2 points A and B with these position vectors, right? And you have this plane which has this equation. Usually we will rewrite it later in scalar product form. This is the Cartesian form. Show that B lies in the plane P. This is simple enough. All right. This is the scalar product form of the equation of P. We will substitute OB into the left-hand side of the equation. Note the phrasing. We will substitute into the left-hand side of the equation. That means here, this left-hand side. So, I will say left-hand side, OB has coordinates. B has position vector 3, minus 2, 1. They get 2, 4, 3. You don't jump straight into the final answer. I know it's not difficult, but usually what we will write is you do the multiplication like that. 1 times 3. In the end, okay, you get 1. So you're happy to get 1 because this is then the same as the right-hand side of the equation of the plane. Therefore, this is equal to right-hand side. Then we conclude, hence, B lies in P. I think this first part is simple enough. The next part, let's go back to the question. Next part, find the Cartesian equation for the line AB. So you have points A and B. Of course, this is not difficult. This is equation of line. Let's very quickly get it done. All right. First, you have to find the direction vector, which is AB. I think maybe you would like to write this is A, this point is B, somewhere there is O. So first I need to find the direction vector AB, which is OB minus OA. I noticed when I marked CT1, I realized some of us got the wrong way around. You say AB is OA minus OB, which is wrong, not OA minus OB. It's wrong. It is actually AB is actually OB minus OA. So let's get this right. You make this mistake right from the start, you lose a lot of marks later on. Yeah. Also, please. Yep. So once you get a direction vector of the line, you got one position vector of point. This one can be OA or can be OB. So recall, the equation will not be unique. So how do you then convert this form to the Cartesian form? Usually I will not memorize. All right. Actually, there is one missing step. Usually I tell my students there is one missing step when you convert this to this, right? I would write it like that. Since x equals to s, y equals to 4 minus 2s, z equals to 7 minus 2s. So from here, this is what we call the parametric form. Then I can easily convert this into the Cartesian by making S the subject. Right? We make S the subject. Making S the subject. Then I'll get it. Right? Making S the subject, then I'll get X equals to y minus 4 over negative 2 equals to z minus 7 over negative 2. I think that's fine. You can leave it like that. Okay, good. Now, third part. Sorry. 14, example 14, third part. Find the acute angle between AB and the normal of the plane at B. So, to find the acute angle between a line and the normal, I think we just learned it in vector 6. So let's practice what we have learned. All right. So first, we use cosine theta. Cosine theta, all right, is, recall, to find angle between line, two lines. Actually, you are just angle between two lines, this line and this line. You just make use of the two vectors, which is AB, alright, which is AB. Look here. Sorry, I just go back very quickly to this one. Why did I not use 3 minus 6 minus 6 here? Of course you could have. Alright, this is actually, sorry, I erased this very quickly. This is actually 3 times of 1 minus 2 minus 2. So I used it here. Now, could you have written 3 minus 6 minus 6 here? Of course you can. There's no problem. There's no problem. So let's go back. You are trying to find the angle between this AB line, 1 minus 2 minus 2, and the normal of P. Normal of P is this one. This is the equation of P. 2, 4, 3 is the normal of P. So, therefore, cosine theta, is 1 minus 2 minus 2 dot 2, 4, 3 divide by the magnitude, and in this case magnitude is root 9 and root 29. Yep, then you simplify, you get this. You get minus 4 over square root 29. You press calculator, you realize that this angle happened to be obtuse. So recall, what do we do with obtuse? Alright, because you only want the acute angle. So you take 180 minus the acute angle. Obtuse angle, sorry. Then you will get the acute angle. Yep. That's that. Let's go back to the question again. Oops, sorry. Here. So, we've done that. Hence, find the perpendicular distance of A to the normal. Perpendicular distance of A to the normal. Let's take a look at the diagram here. Alright. I think this diagram is very, very informative. First of all, we have shown that B lies in the plane P. So what's good? Next, we have formed the line AB and we have found the angle 42.031 as the angle between the normal and the line. Yes, A lies somewhere out there. Now the question wants us to find using this to find the perpendicular distance from here to the plane. Sorry, to the normal, I beg your pardon. To the normal here. This is therefore the perpendicular distance from A to the normal. Let's get this diagram sorted out. Okay, that's very, very clear. Again, I say again, B lies in the plane, A is somewhere out there on the line. You have found this angle 42.031. You want to find this distance D, which is the perpendicular from A to the normal. I think the answer is out, because if I can simplify this here like that, this becomes a triangle, a right angled triangle. This is 42.0 degrees. I want to find D. If this is A, this is B, if I know what is AB, then I'm done. Correct? So that is the approach I'm going to use. Alright. AB is not difficult. AB, vector AB is 3 minus 6 minus, which we found earlier. But do not reduce. Now you don't write and you don't. Now you cannot reduce it to 1 minus 2 minus 2. This one wrong already. Or because AB is now a vector. I just want to find the length of AB, and this is the length. Yes? So length of AB you calculate, you get 9. Correct? Magnitude of a vector, you get 9. So now I tell you this is 9. Correct? This is a poorly drawn right angle triangle, but never mind. This is 9. This is angle 42. I want to find D. Trigo will tell you what to do. Yes, you will. If you learn your Trigo well enough, I think this, you will use the what? Trigo ratio? Yes, very good. Sine, because you are using opposite over hypotenuse. Yes, so therefore this is perpendicular distance is 9 sine 42.031 degrees, which is 6.03. Yes. Okay, last part. Find the equation of the plane which contains AB and is perpendicular to B. So you have a plane, yes, that contains AB and perpendicular to B. Now, I just want to emphasize that usually we will want to find the equation of a plane in scalar product form, but in this case, they didn't tell you what form to give. So it needn't matter. Whatever form that you can give, you just throw to them. In this case, I would give the answer in a vector equation form. Why? Because the vector equation form, maybe I write down here, is like that. R equals to something plus S something plus T something, where S and T belonging to real, right? So, are we able to very quickly write down what is this here? This is a position vector of one point on the plane. I repeat, this is a position vector of one point on the plane. Do we know one point on the plane? Of course, because the question say that the plane must contain AB. This new plane must contain AB. Correct? Yes, and it's perpendicular to P. Later we use this, but so definitely I know what is one point on the plane, which is either A or B. In this case, I use A. Okay? I use A. So, not difficult. I can immediately write this down. Now, this is 0, 4, 7. Now, I don't think it's difficult to write this vector down as well, because since AB lies on the plane, then I am very sure that AB, that vector AB is parallel to the plane. So I can use 1 minus 2 minus 2. So all I need to do is to find this one, another vector, yes, that is parallel to the plane. To find this, let me go to here. Okay lah. So it contains AB, so this is parallel to 1 minus 2 minus 2, right? Because it contains the line AB. This one easy. Next here. If Q is perpendicular to P, Q is the plane, the required plane is Q. It's perpendicular to P. Then can I safely say that Q is parallel to the normal of P? It's not, let me draw it like that. Okay, maybe I shouldn't draw. I use two perpendicular planes, I show it to you like that. Okay, wait, look at the camera head now. Look at the camera head now. If these two planes are perpendicular, okay, Q and P are perpendicular, then can you then see that the normal of the green plane, can visualize, I don't have three hands, the normal of the green plane is parallel to the white plane. Right? The normal of the green plane is parallel to the white plane. So that's all we are saying. Yes, the normal of the green plane is parallel to the white plane. Replay it a little if you are not very sure. Alright, so therefore Q is also parallel to the normal of P. Normal of P happen to be 2, 4, 4. Yes, so I think we're done. This is just 2, 4, 4. Yes, so that's that. Very tempting for all of us sometimes to just want to find normal. But the question very clearly did not ask, look at the question again. The question just say find the equation. They didn't say find in scalar product form. Correct? In the plane that contains this and this. So of course, if they ask for scalar product form, I repeat, if they ask for scalar product form, what would you do? You would take this, cross this to get the normal vector. Right? Yes? So, of course, you can use a diagram. I think this diagram works well. This is A, this is B. Yes, just now I tried to use the green file to show you that this normal vector must be parallel to the plane itself. Alright? Okay, good.